In this lesson, we're going to verify trig identities, which means basically you have an equation and you have to pick one side, work with that one side to make it equal to the other side. You cannot do things to both sides in the proof. So here are some guidelines to help you with that. Pick the more complicated side and work with that. Now, most of the times that'll work. Once in a while it won't, but that's a good start. And there'll be times when you do things that are correct, but it won't lead you to the right answer. So you just cross it off and try a different approach. Identities that you've learned so far, you're going to want to use, and then you have to know how to combine fractions, rewrite fractions, multiply and factor. And if things don't work, last resort, change everything in terms of sine and cosine, and then that sometimes works. What we're going to do is just one algebra piece, which is factoring the difference of squares. So a squared minus b squared is equal to a plus b times a minus b. But also along with that, we can do the same thing for the fourth power. So a to the fourth minus b to the fourth is going to equal a squared minus b squared times a squared plus b squared. Again, looking at the middle terms, they would cancel and you're left with those two. So just a quick reminder that you can do it to the fourth power as well as the square power. And so I'm going to do 4 problems on working with one side to get it equal to the other side. The first one is looking at these two expressions. Notice that you have 2 separate terms here. Now I know that I can get this into one term by combining like fractions, and this is more or less one term that has multiplication of 2 terms. But I'm going to work with this side and use the reciprocal identity, and then change this by multiplying it by cosine over cosine, so you have like denominators. At this point, it's 1 minus cosine squared over cosine theta. Again, notice that I'm working down, only with one side. Now, this right here is the same thing as sine squared theta, because sine squared theta plus cosine squared theta equals 1. And you would just subtract a term off of both sides, and you would see that that would equal. And so that is going to be over the cosine theta. And now I'm looking at this side, so I know that sine theta has to exist. And now you're left with the sine theta over cosine theta, which is your tangent theta. And once you get to the end and it matches, then you rewrite it, and that's the proof of showing, verifying the trig identity. Going to this one, secant theta. Secant theta is the same thing as 1 over cosine theta. So what I really want is to get to is 1 over cosine theta. In other words, this has to be reduced in terms of just cosine. So let's see how that works. Sine theta, what I'm going to do here is convert to sine and cosine because you can't add. So this is sine theta over cosine theta, and this is cosine theta over sine theta, and I want like terms, like denominators. And so I now have like denominators, and you can see the top is shaping up to being a Pythagorean identity. It's sine squared plus cosine squared, which is really 1. And the bottom is going to be cosine theta times sine theta. Sine thetas cancel, and you're left with 1 over cosine theta, which is secant theta, and that's equal to secant theta. It's a good feeling when you get the right answer because you know it's right with your substitutions. Let's take a look at number 3. we're definitely working with the left side. It's more complicated. And just convert in terms of sine and cosine. This is the quotient property. This is the reciprocal property. And we leave this the same. I can see that the cosines will divide out, the sines will divide out, all leaving ones, and therefore 1 equals 1, and you're done with that one. Number 4, we're looking at something where we're dealing with a lot of squares. So I would get the Pythagorean identities nice and handy. That identity sheet should be right in front of you, but this is part of the identity sheet. And you can see that the cosecant is equal to the cotangent squared theta plus 1 minus the cotangent squared theta. And the bottom, you know, sine squared plus cosine squared equals 1. So this is really going to equal the, that wasn't good. That's really going to equal the cosine squared theta. Now, cotangent squares cancel, so you're just left with 1 over cosine squared theta, which is the same thing as secant squared theta. Again, once you get the answer, you rewrite the other side to show that you have it. So there's a variety of techniques to use in order to prove the identities. And again, you only can choose one side, work down, and don't touch the other side until you get to the end.